In this video, I'm going to talk a little bit about exponential growth and exponential decay. And starting from the formula, A of t, like a final amount, it's A naught e to kt. A naught is the initial value, t is the time, k is a positive constant that determines the rate of the growth. And then we'll talk about the decay, but let's focus now on the growth. So in many problems, when they want us to find the function or they want us to find the time, they give us r, the rate. So they say it increases with 3% or increases with 5% or something like that. So the question is, if r is given, what is k? So what am I going to replace to actually be able to find the exponential function for growth? So this is what we have to do. So let's say day or time 0, the initial time, the amount is the initial amount. After one period, 1 year or 1 day or whatever the time it's measured in, we have the initial value plus r% of that initial value. So this, it's equal to, if I factor out a naught, 1 plus r. So it's a naught times 1 plus r. After 2 periods of time, whatever, days, years, and so on, the amount that we have now, a naught times 1 plus r, is going to be added r% of that. So it's plus a naught 1 plus r times r. Now we also notice that a naught times 1 plus r, it's a common quantity, so I'm going to factor it out. And then it's going to be times 1 plus r, which means we're going to get a naught times 1 plus r squared. So we can conclude that time t, so after t years, t days, the amount, a of t, is going to be a naught 1 plus r to the t. And you can actually do more steps if you want to. The key is factoring common factors. So the question is, how do I get from what we obtained here to the function that we started with, the yellow one? Well, the key is to change this quantity from the base, that exponent, from base 1 plus r to e. So that means, if you remember, a to b can be written e to ln of a to b, which means e to b ln of a. So that's how we change from any base to base e. So this will become a naught e to t ln of 1 plus r. Or in other words, again, if we compare this quantity, this final one, what we had above, we can see a naught, e, the t, and then we can just say k, it's equal to ln of 1 plus r. So what I'm trying to say here is, if the problem gives you the rate of increase, then don't just plug it into a naught e to kt, but because k and r are two different things, but calculate k as ln of 1 plus r. Now let's take a look at the exponential decay. So let's say we have the function a of t equals a naught e to kt. That's the function that we start with, where a naught is the initial value, t is the time, and k is a negative constant that determines the rate percentage of decay. So my question is here, if it's given r, the percent of decay, if that's given, then what is k. What am I gonna replace in here? Because obviously I'm not gonna replace k with r. So we're gonna do like we did before. We're gonna want to figure out what is the value of k. So to do that, we say time 0. So at the initial time, the value is a0. After one period of time is gonna be the original value minus a0 times r. So we subtract the r percent of a0. Now if we factor a0, we get 1 minus r. After 2 periods of time, the value changed to a0 1 minus r, and then from minus, and from this value we subtract a0 times 1 minus r times r, because it's another decrease. Again, the key is to notice that a0 times 1 minus r, it's common, right? It's here and it's here. So we factor it out and we end up with 1 minus r again, which means a0 1 minus r to the second. I'm going to do one more time. So 3 days, 3 years. The new value is a0 1 minus r to the second. And from this one, we subtract a0 times 1 minus r to the second times r. So we factor out a0 times 1 minus r to the second, and then we get 1 minus r, which gives us a0 times 1 minus r to the third. So now we notice that after time t, we are going to get a0 1 minus r to the t. So in other words, the final amount or population or whatever we have is going to be a of t equals a0 1 minus r to the t. But this one we can transform into base e like we did before. So it's a0 e to t ln of 1 minus r. So in other words, so a of t is this one, and in other words, k it's equal to ln of 1 minus r. So when the growth rate, or the decay rate is given, we can calculate k and then replace it into the function. I hope this helps.